Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to solve radical equations. Alright.
In solving radical equations, we're going to use squaring property of equality. So if you want to remove a square root symbol, we need to get the square of both sides. And we can also use the cubing property, which is if you want to remove or eliminate the cube root symbol, we are just simply going to get the cube of both sides of the equation. Here are the steps in solving radical equations. So first step is for us to isolate the radical term. If there are more than one term, just pick one radical term that you want to isolate. And then second step is for you to square or cube both sides of the equation in order for you to eliminate or to remove the radical symbols. Okay, step 3 is for you to make sure that you don't have any radical expression. If all radical expressions or terms have been eliminated, then solve for the value of the variable that you're looking for. And step 4 is for you to check your solution. Now, let's go on to our examples. Okay, let's have an example. For example, we have this equation. First step is for us to isolate one radical expression. So since the radical expression is already isolated, we're going to proceed to step 2. For step 2 is to eliminate the radical symbol by applying the squaring property or the cubing property. Since this is the square root, we're going to use the opposite of square root, which is squaring. So we're going to square both sides. Ayan. So we're going to square both sides of the equation. Okay, to eliminate or to cancel out all radical expression. So cancel the radical symbol and then simplify. So let's proceed to the next step is to simplify. So we will have x plus 5 is equal to 16. And then we are now going to apply subtraction property by subtracting both sides by 5. So let's subtract both sides by 5. Minus 5 to isolate the expression x. So we have x is equal to 16 minus 5, we will have 11. And that will be the value of the variable. Now, after getting the value of the variable, we're now going to apply checking. So in checking, we're just going to substitute the value of x that we got to our original equation. So we will substitute 11 to our variable x, and then let's see if it will satisfy our equation. So we will have 16, square root of 16 is equal to 4, and then what's the square root of 16? That is equal to 4, and then 4 is equal to 4, then it satisfies our equation. Therefore, we can now conclude that x is equal to 11, or 11 is the value of x. Okay, let's have another example. So for example, we're given this equation. So first step is for us to isolate our radical term. So in this case, we need to isolate cube root of 2x. So in order for us to isolate that, we need to use addition property. So we need to add both sides by 7. So we will have the cube root of 2x is equal to positive 2. And then after that, we're now going to apply the cubing property. Since our index is 3, we will use the cubing property. So we're going to use the cubing property to eliminate the radical symbol. So cancel. So let's simplify. So we have 2x is equal to 8. Divide both sides by 2. Divide both sides by 2. Okay, so x is now equal to, that will be the value of x that we're going to check. Okay, so let's check if x is equal to 4. Now, after getting the value of x, it is time for us to check if this is the true value of x. So we have to check by substitution. So let's replace the value of x by 4 and then simplify if both sides will satisfy each other. So let's simplify. We have the cube root of 8 minus 7 is equal to negative 5. What's the cube root of 8? That is equal to 2. Minus 7 is equal to negative 5. Now, 2 minus 7 is negative 5 is equal to negative 5. Now, are they equal? Yes, it satisfies our equation. Since it satisfied our equation, the true value of x will be equal to 4. And that will be our final answer. Okay, let's have another example. For example, we're given this equation. So, first step is for us to isolate one of the radical terms. So, once we isolated it, we're going to apply the cubing or the squaring property. So, in this case, we will choose this as our isolated radical expression. Now, we can apply the next step, which is the cubing property by getting the cube of each side. Now, after that, let's simplify. So, cancel. We cancel this. Okay, since this is also cube, we cancel that. Then after that, we will have 3x minus 12 is equal to 2x minus 6. Now, let's solve for the value of our variable by applying the different properties. So, let's isolate all the variable term in one side and all the constant term in the other. Let's transfer negative 12 to the other side and positive 2 to the other side. Now, take note, when you transfer, you will change the sign. You will now have 3x minus 2x. So, we transfer 2x to the other side and we will change its sign. So, we have negative 6 plus 12. So, again, when you transfer a term to the other side, you will always change the sign. Okay, so now combining like terms, we have x is equal to positive 6. And that will be the value of x that we're going to check. That's not yet our final answer because we're going to apply the checking. So let's write it here. Now, let's check whether our value of x is equal to 6. So in order for us to check that, let's substitute the value of x to our given equation. So 3 times 6 minus 12, is it equal to the cube root of 2 times 6 minus 6? Okay, so let's simplify. So 3 times 6, that is equal to 18 minus 12. Let's copy the radical symbol. Okay, 2 times 6, that is equal to 12 minus 6. Then combine. So we will have cube root of 18 minus 12, that will be equal to 6. So we have cube root of 6 here. Is it equal to the cube root of 12 minus 6? 12 minus 6 is also 6. Since these two sides are equal and it satisfies our equation, we can now conclude that our variable is equal to 6. Alright, okay, so let's have another example. For example, we have this equation. So first step in order for us to solve for the value of x is for us to isolate one radical expression. So in this given, we have two radical terms. So we're going to just isolate one radical term in our first step. In this case, since the square root of the sum of x plus 5 is already isolated, so I'm not going to transfer any terms in this equation anymore. So I'm going to apply the second step, which is to square both sides. So since our radical symbol is the square root symbol, we're going to use the squaring property to eliminate or to remove the radical symbol. So let's square both sides. Square both sides. Okay, now for squaring this, let's square the left side. So we're just simply going to cancel the radical symbol and the square symbol. So we will have x plus 5 is equal to, now for our right side of the equation, since 5 is not inside the radical symbol, we're going to apply squaring a binomial. So to square a binomial, we're going to either multiply square root of x plus 5 by itself, or we can just simply apply the shortcut. Now the shortcut is, for square of a binomial, is to square the first term, plus 2 times the product of the first term and the last term. Then plus the square of the last term. So that's the shortcut. If you want, you can apply the FOIL method. And first, outer, inner, last. Okay, so let's combine like terms, or let's simplify. So we have x plus 5. Now we have x plus 10 square root of x plus 25. Since we still have our radical expression, let's isolate 10 square root of x. So let's transfer square root of x and positive 25 to the other side. So let's have, okay, so we have x minus x plus 5 minus 25 is equal to 10 square root of x. Let's simplify. We will have negative 20 is equal to 10 square root of x. Then let's divide both sides by 10. So let's isolate the radical symbol. So divide both sides by 10. So here we will have negative 2 is equal to square root of x. Then after that, we're going to square both sides. So square both sides. To eliminate the radical symbol, square both sides. So we will have 4 is equal to x, or x is equal to 4. So we're not yet done, because our last step is for us to do the checking. So our value for x is 4. So let's check if 4 is the true value of x in our equation. We need to substitute the value of x to our given equation. So substitute. We have square root of 4 plus 5 is equal to square root of 4 plus 5. Now, so 4 plus 5 is equal to 9. So we have the square root of 9, and we have square root of 4 plus 5. Now, what's the square root of 9? That is 3. Square root of 4 is 2 plus 5, that is equal to 7. So 3 is equal to 7. Are they equal? No, they are not equal. So therefore, since 4 did not satisfy our given equation, we consider the value of x, which is 4, an extraneous root.
Extraneous root is an apparent solution that does not solve our equation. Ayan. So when we encounter extraneous root, our final answer will be no solution. Okay?
So since 4 did not satisfy our equation, we can say that in this equation, there is no solution. Because x is equal to 4 is an extraneous root.
Now that you already know how to solve radical equations, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video.